Hello. What is up, YouTube? Apologies, it's been a while. I had jury duty the last 2 weeks, so I've not been about, and also launching a website today, so it's been really busy. But I'll see if I can squeeze this in. So if you're joining, if this is your first time, welcome. We're going to be doing some JavaScript. If you're in the chat, let me know how good or bad your JavaScript is, and I'll try and aim it at you. But my code will be available here. You should see it in the live chat on YouTube now. And the challenge we'll be doing is day 18 of the Advent of Code challenges. This is a great set of quite difficult challenges. You can see I've only fully completed 4 of the last 17 I've done. We're trying to time box into about an hour, so it should be quite quick. Quite a good just exploration, sort of a breakdown of how we do work through these kind of problems. They tend to be quite like algorithmic and similar to like a coding interview style, which most people aren't very good at unless they revise. So don't worry if it goes over your head or if it goes over my head, which again it very likely will. But otherwise, let's get started. So I've put in this snippet already, just all the code you need to read like an input file in. So you will have that available in your input, just because most of them require us reading in some sort of text file. But let's have a read through and see how far we get. Oh, thanks, Friendly Octopus. Okay, day 18, Snailfish. You descend into the ocean trench and encounter some snailfish. Oh, I don't like that. I wonder why they're called snailfish. Anyway, they say they saw the sleigh keys. They'll even tell you which direction the keys went if you help one of the smallest snailfish with his math homework. Hello, brave girl. Snailfish numbers aren't like regular numbers. Instead, every snailfish number is a pair, an ordered list of 2 elements. Each element of the pair can either be a regular number or another pair. Oh, I already don't like this. They always tend to just fall down into like tree traversal of something or recursive functions. So this is looking pretty familiar anyway. Pairs are written as x, y, where x and y are the elements within the pair. Here are some example snailfish numbers. 1 snailfish number per line, so we can use this as our input, as I said before, and pop them in this input file, and then we'll be able to access them over an array because of that handy stuff I already popped in there. Okay, the Snellfish homework is about addition. To add 2 snailfish numbers, form a pair from the left and right parameters of the addition parameters. For example, 1, 2 plus 3, 4, 5. What? Oh, right, okay, you form a new pair, I see. There's only one problem. Snailfish numbers must always be reduced, and the process of adding 2 snailfish numbers can result in snailfish numbers that need to be reduced. To reduce a snailfish number, you must repeatedly do the first action in this list that applies to the snailfish number. If any pair is nested inside 4 pairs, the leftmost such pair explodes. If any regular number is 10 or greater, the leftmost such regular number splits. Once no action in the above list applies, they're then reduced. So this sort of makes up everything we're going to have to code in here. So I'm just popping that in a comment with this double slash so that it doesn't affect how our code runs. During reduction, at what website are we using to input the code? We're using Repl it. Sorry, I didn't mention that before. So there's a link to my code, but if you want to make your own somewhere else, you can do. But Repl it is a good place to just start writing JavaScript code or Python code or whatever code you want to use. Okay. Pricing in a time series sort order. Oh. I'm not sure I'll be able to help you with that, brave girl. We're already working through this challenge. Anyway, during reduction, at most one action applies, after which the process returns to the top of the list of actions. For example, if split produces a pair that meets the explode criteria, that pair explodes before other splits occur. To explode a pair, the pair's left value is added to the first regular number to the left of the exploding pair. Wow, this is a big one. If any, and the pair's right value is added to the first regular number to the right of the exploding pair. Exploding pairs will always consist of 2 regular numbers. Then the entire exploding pair is replaced with the regular number 0. Here are some examples of a single explode action. What on earth? The 9 has no regular number to its left, so it's not added to any regular numbers. Man, I have no idea what this is talking about. Okay, to split a regular number, replace it with a pair. The left element of the pair should be the regular number divided by 2 and rounded down, while the right element of the pair should be the regular number divided by 2 and rounded up. For example, 10 becomes 5, 5, 11 becomes 5, 6, 12 becomes 6, 6, and so on. Splitting looks a bit easier then. Apologies, Chris, I'll slow down. I'm just reading through the whole exercise now to try and get my head around it, though. I'll link the challenge again, so if you do want to read it on your own time, you can read it there. Here's the process of finding the reduced result of this input after addition. 4, 3, that 4, 3 is already there though, so I guess it's the adding of this in. Then they find the first explode, which is the 8, 4. They explode it. I don't really understand what exploding is, so I'm going to leave that for now. They split the 15. These like highlighted bits don't really make much sense. That's the split 15. Then the 13 is split. Ah, I see, that's why it's highlighting it now. 13 is split into this. Once no reduced action applies, the Snailfish number that remains is the actual result of the addition. Okay, so we don't actually have to do the addition. The homework assignment involves adding up a list of Snailfish numbers, which is my puzzle input. So everyone who signs up for this will have a different puzzle input that you can see here. So here's mine. It'll produce an answer that won't be the same as what you get. So you could copy the code, but you can't just copy my answer at the end. Okay. So that's adding up a list of the Snailfish numbers. Snailfish numbers are each listed on a separate line, and the first Snailfish number and the second. So let's take this. Actually, there's no addition in there. So we could just start with this number and see if we can isolate those individual pieces. So we'll probably try and replicate this first, even though I'm still not really sure what exploding is. Oh, here's an easier one actually. So the final sum of this. Add up a list of numbers. Snailfish numbers are each listed on a separate line. Add the first Snailfish number and the second. Then add that result and the third. Then add that result and the fourth. So on until all the numbers in the list have been used once. For example, the final sum of this list is this. The final sum of this list is this. Gosh. I'm very, very confused. Check whether it's the right answer. The Snailfish teacher only checks the magnitude of the final sum. Magnitude of a pair is 3 times the magnitude of its left element plus 2 times the magnitude of its right element. What on earth? Right, so let's not worry about the magnitude either. So where can we actually start here that starts simple? I don't really see where this becomes this. I guess because the items of the list. Chris, you'll have to read this whole example. This whole page explains like what all these numbers are. But they're basically like an encoding of our numbers, except they're stored in these number pairs. So you can still do addition, but that's what all of this page will explain. So you'll have to read through that. I did just read through it, but I didn't really understand it either, so we'll have to break it down a bit at a time. So I think we're going to have to add all these numbers up first before doing anything. process of adding. So first we need to do this sort of addition. So I think we can basically add them by comma separating them into the same list, it looks like. So we can do, trying to think like what's an actual useful starting point. Maybe this. So if we run it, do input, you'll see that we've got both of those things. What we really need to do is insert this one into the right hand side of that, it looks like, to sort of replicate this behavior, which should just be putting them into a new array, right? So we can say const, so I'm going to define an addition function, and that's going to take our left number and our right number, well, they're not really numbers, they're pairs, and then it's just going to return a new list with the left number comma separated by the right number. So this is what's called an arrow function. It's quite a sort of modern JavaScripty thing. We could define a function otherwise. We could even get rid of all these returns and just write that as a valid line of code. And then that can be called on our inputs. We could say addition input 0, input 1, and it should give us the addition of both of them. Oh, it doesn't. Oh, well, it does, but it kind of needs to be like the string of that. Can I do that? Addition input 0, input 1. This one is quite hard, so I appreciate there's a lot of people here today. I have made like 18 other videos like this that are probably going to be easier than this one. Maybe look at some of the first ones in the series. They might be a bit more simple to follow, I would say. Well, let's put this in here. So let's say log addition input 0. So that's our first item in our strings in this other file here. So input 0, input 1. Running it should add them together. Get rid of that string for now. Right, so that looks close to what we want. So I'm expecting something like this, though there shouldn't be. It should all be a string basically. So it should be like, can I do that? I guess I could do a string literal like this. So this lets us put variables inside our string. It will let us get a string instead of a list or an array. So there we go. So that's more like what I'm looking for. So that's a sort of a working addition. So we should be able to try adding, say, these two things. If that's our two numbers, we can do this. And that gives us, let's just check if that's the same thing. Oops. So there we go, open, 1, 2, close, comma, open, 3, 4, close, 5, close. Okay, so we've got our array now. So that's addition hopefully done. I guess we need to chain it for everything in the file. So is there an example of multiple things being added together? These kind of feel like they're backwards, right? Like this should be an example to get the other way. Sorry, I realize that's not making any sense. So let's see what happens if we run this. It's obviously only going to look at the first two, and it gives us that 1, 1, 2, 2 with one wrap. But what we actually need to do is for each item in the list, we need to add them together. So we could do const add all rows equals, that needs a rows object, which we already have. That will be our input function. For row in rows. Oops, that's Python. Rows dot for each row, and then we can say, let's say output equals an empty string. Then we can do output equals addition row be output comma row, and then I should just be able to pass everything into that. I'm not sure that's going to work. I feel like it's going to mess up on the first sort of go round, but let's see. Oh, rows is not defined. It should be input. Undefined. Okay, I didn't return anything. I need to return output here. Hey, that looks pretty good. It looks like we might have an extra. I mean, there's definitely a null one that's been popped in at the start. So we're looking for this, but we're getting this. So I think the difference is just this comma, right? So how can I get rid of that? It's because the first time round this is doing this added to input 0, which isn't going to work. So how do I skip that first one? I guess we could define output start as input 0, and then instead of for eaching, because now we're going to have 2 1s, I just need to skip the first one. So I could do like for. Yeah, Chris, what level's your JavaScript at, just so I know where to aim it at? I think it's, as I say, this is going to be quite a hard one, so I'm not sure we're going to get very far through this, but I'll try and explain what I'm doing while I'm doing it too. Nice. Right, I will take a step back a little bit. So I guess I've not got my head fully around the challenge yet, but what it looks like is that we're going to get given a list of these numbers, and they're a bit weird, but it says here what the numbers are. So each number is an ordered list of 2 elements. Each can be either a number or another pair. So we could just see 1 and 2 here, like we do, but we could also see in that pair x is equal to 1 and 2, and y is equal to 3. That doesn't mean much to us because this isn't how we normally do it. But the benefit of this sort of way of writing numbers is that adding them together is just as simple as putting them in the same list. That is addition. And that's defined here. It's about addition. But snailfish numbers must always be reduced, and the process is here for what is reducing a number. So the first one that it lists, so if any pair is nested inside 4 pairs, then the leftmost pair must be exploded. So if we look at this one, for example, this one has 4 pairs. So this one will need to be exploded, I guess. I'm not too sure on that, but there's a lot of discussion on what exploding is. Here's an example of this. This one needs to be exploded, and that's what exploding is, but I don't really understand exploding yet. We'll get to that in a second. The other one is splitting, so if any number is 10 or greater, it needs to be split. So that is shown here. So 10 would become 5 and 5, or 11 would become 5 and 6. So splitting looks a bit easier. We'll probably start with that. And then once it's finally reduced, we can add up a list of all those numbers. And that's where we start getting larger examples with their final sums. It's a bit confusing. This is not an easy one. And then eventually we have to calculate the magnitude of each answer, which is defined down here, but we probably won't even get to that considering we're about halfway through the time already. So looking back at the code, what we've got so far is I've got this file, and again you can see this in the Repl I've sent. So this will let you put any number of those numbers in here, and you can run the code with it. So you don't need to worry about importing other files, because the code for that is up here, but I think that's a bit more difficult. It requires me to explain, what's a function, what's a library, how do you import those libraries, what's reading from files, things like that. So it's not, there's a lot of stuff here that I would just say for now, if it's early days for you, don't worry about it. Then the next thing I did is defined a function. So there's quite a few ways of defining a function in JavaScript, but sort of the new and sort of common way is to define something. So let's say const function name equals, then in round brackets we have our parameters, so parameter 1, parameter 2, then an arrow, and then in curly braces we can write what we're going to return. So in this case, say I just want to add those two numbers together. So now I've got that, I can do function name, I could give it 1 and 2, and I'll get back a 3 in this Repl over on the right hand side. Obviously function name isn't a great name for that, so you can have a think, what's a better name for a function that adds two numbers together? What's a better name for parameter 1 and parameter 2? So I might say add two numbers. I might call this one num1, I call this one num2 instead. And then now if I click this run button again, I can now access that function, add two nums, and I can give it numbers to add. Okay. And that's all I've done on this next line. There's a slight refactor in that if you're just returning one thing, if you're doing one statement, you don't actually need the return or the curly braces. So that is just as valid a function. And again, we can see that with add two nums, we can give it 1 and 1, and we'll see a 2. So that's one of the ways to write a function in JavaScript. This const word means that it's a constant that will never redefine the function. I think we could also define the function with let, maybe with var, I'm not too sure. So these are again 3 different ways of defining variables or functions in JavaScript. So const for constant, var for variables, let is sort of the new equivalent of constant for variables that change. But we're not going to need that. So I've written a first function, addition, that does what I think addition is just based on this example. So given two Snailfish numbers, we're just going to put them in the same list. That's all that one does. So we can try that out. We could say addition, and I could give it 1, 2, and I could give it 3, 4. And it pushes them all together. That's wrong. Why has it done that? Well, that's not a good start, but it has like removed one layer of the brackets for some reason. Perhaps because they're not strings, so it's interpreting them as lists. So this is more like what we're doing in the file, because everything in the file is a string. There we go. Okay, so that addition function is important. That means that we can now replicate this behavior, but our input isn't just going to be two things. It's actually going to be a file. of multiple ones. So I've instead written this next function called add all rows. It's got a parameter rows, which can be in brackets. It doesn't have to be if there's only one parameter. Arrow function, open braces. I'm defining an output object that I'm basically going to use as an accumulator to sort of build up the rows as I get to them. So maybe I'll write in here the output just so we can see it building up. So you can see that it gets the first one, it adds in the 2, 2, adds in the 3, 3, adds in the 4, 4, and we're done. We do that in this for loop. So hopefully from Java you're familiar with for loops, but the first statement is what's sort of our iterator. So we define our iterator. So normally you might see an I, but we could call it counter, we could call it robot, we could call it whatever we want. I is sort of a shorthand for index. And that's kind of what we're doing here. We're sort of indexing those rows. So I'm skipping the first one because I've already put the first one into the output object because we had like a weird formatting issue. Then we're counting up to the number of rows we have. So while the index is less than the number of rows, increment the index, log out for each time we run it, and then sort of append this to our, well, use the addition function we used before to grow that output object, and then at the end return that output object. So when we do call it, we get this from the end. And then I've done some console logs. So console.log is a function, and then in there you can just pass parameters for it to print out. So we don't really need to look at addition anymore. We don't need to keep this console log. So now we've got the successful addition of all those rows as is defined in here, right? The final sum of this list. Oh. Numbers are each listed on a separate line. Add the first to the second, then add that result to and the third, add the fourth, and so on until all the numbers in the list have been used once, which we did do. Though, I'm guessing this requires us to do some sort of, the reduction hasn't been done yet, this reduction that's described up here. I'm hoping that that's the difference between this and this. But for now, this is an example that doesn't require any splitting or any exploding. So we have the correct answer, I'm hoping, although it feels kind of like I've done it backwards. Like, that doesn't look like an addition. So I don't know, I'm a bit confused by this example as well, but I'm just trying to take the bits that make sense to me. So what comes next is probably looking for any splits, right? So we had this, and we need a split on the 15 and 13. So let's start with this number. And that should read in okay, there's nothing to add up. So given that number, we want to get this number after one split. So we should be able to call a split function. Split function, it should take that number we've got as an input, and it should be splitting the 15 into a 7 and an 8. So we're looking for the first number that's 10 or above, I believe. So let's start with that. So maybe find first. Let's see, find split. That will take our, I don't know, I guess it's a number. And in here we're going to look for the first 10. So I don't really know how we're going to split. I guess, if we remove all of the brackets, we'll just be left with our numbers, right? So remove all instances of a character JavaScript. So here we go, we can use replace all. So we can say number, well, we might be able to just return, no, we don't want to do that actually, console.log, number, replace all, and I want to get rid of the brackets and replace it with nothing. There's no return. Sorry, I need another bracket there. Oh, I haven't called find split. Find split needs input. Ooh. Number.replace all is not a function, so it has to be a string. Is input not a string? Oh. Let's leave that out and see what input actually is. Oh. Oh, weird. So it should be input 0. Let's try that. Input 0 should be a string. Type of input 0. It is a string. So what is it complaining about? Number. Maybe number is a protected word. I don't know. Let's try doing that. Nope. Number.replace all is not a function. If I spelt it wrong, have I done anything? And that looks okay. I guess maybe I can't console log that because that's not a string. No. Replace all is not a function. Right, I'll try using this replace method. Instead, it looks like this one's not necessarily supported. Maybe I'll borrow this function. So someone's written a replace all function that we could use that might be a bit easier. Oh, it's right there. Place all is declared but is never used. So this one needs slightly different parameters like that. Site complaining about escape regex. Oh. Alright, let's go back to using this replace then. What are strings? What an interesting question. I guess I skipped over that today. So when we have stuff like this, right, this on the right hand side is called a Repl, R-E-P-L. So that stands for read, evaluate, print, loop. And that's exactly what a Repl is doing. So if we type in something like 2 plus 2, then it's reading 2 plus 2 as a string. It's evaluating that as 4. It's printing out that 4. And then it's looping. It's asking us all of that again. So we can just keep saying if we want 2 plus 2, 2 plus 2 over and over again. It'll just keep running. And this is kind of how languages are read sometimes. We look through the lines, we evaluate that line, figure out if another line is required to make sense of it. And what we end up with ideally is sort of inputs and outputs into a programming language. So let's talk about variables first. So if I had something like a variable, I would say use the variable keyword. I'd have to write a variable name, then I'd use the equals operator to assign something to that variable. So let's say 12. So now I have a variable name that's storing the value 12. So you can imagine that as like a box in your house. You might write on the side, kitchen, and inside it put kitchen items. In this case, that box on the side has written the word variable name, and it just holds the number 12. So we're quite familiar with 12 being a number, right? And in languages, we would call that number the type of the object. So if I call this function type of 12, we'll see that it's a number. That makes sense to us. In JavaScript, we use quotes for something else. So if for example, I said type of cat, it doesn't mean anything. And that's because cat, it's assuming cat would be a variable name. And that variable is obviously undefined because we haven't created that variable. So what we instead do is we wrap strings in quotes. So either single quotes or double quotes or backticks, whatever quotes you like, really. So that type is called a string. And the reason we have different types is that different types have different methods that can be run on them. So for example, the string cat has various string helpers available to it. So there's one called toUpperCase, I think. Oh, no, there's not. toUpper. Is it just upper? Oh, I don't know what it's called. String uppercase JavaScript toUpperCase. Oh, it was the first one I typed, so I just didn't get the toUpperCase like that. And there we go. Then we get a string cat all uppercase. So that's a useful function. We might want to capitalize something, we might not. But for a number, that toUpperCase function just doesn't exist at all. Because it's a number, it doesn't have a notion of uppercase or lowercase, but it does have notions like addition, right? Two numbers can be added together, but cat and dog, in English, we wouldn't say these things can be added together, but each programming language can decide how they deal with that. So in this case, JavaScript has chosen to concatenate those two things together, which kind of makes sense for an addition. It's not too bizarre. So that's strings. There's also all sorts of other types. We've got also a number, 2.1, or a negative number is also still a number. We've got notions of something called Boolean. So these are statements that are true or false. So we could say, is 1 equivalent to 1 is a Boolean because it's going to evaluate true or false. What else has we got? We've got lists, we've got objects. So we're kind of looking at lists already. Oh, it's an object in JavaScript. Again, different languages interpret these things differently. That's also an object. So these are just different data structures we can play with that have different functions associated with them. And a string is just, it's useful to use a string if we want to concatenate things, find numbers within them. I don't know if we have a character type. No, so some languages will have a type for characters that's just an individual character. And then a string is just a list of characters. But I don't believe JavaScript is one of them. I think JavaScript only has like 6 or 7 of these types. Right, so next we get onto const. So as I used before, we could store this variable, say my age 27, in a variable called my age. That makes sense. Now in more recent JavaScript, I think in the last 8 years or so, we've had the addition of what's called the const keyword. So we could say my age equals 27 using const instead of var. Oh, I can't. Let's say your age. So now we have this variable your age. And const is sort of there to protect us from accidentally changing the value of that variable. So if I want to say your age equals your age plus 1, say it's your birthday, that will error because we assigned it to a const variable. And that's us saying we never want this age to change, which is probably a mistake. So the next one is, so it's just how you define a variable that will never change. The other one is let, so we could have like let cat's age equal 12. And this actually will let us redefine it. So we could say cat's age is 12, as we said. Cat's age could equal cat's age plus 1. And that can be incremented, whereas the constant can't be. So we might use the constants for, mathematical values that stay consistent forever, like the value of pi or some sort of constant. We might use it for things that, like an input that we know will never change during our function running, just to make sure we don't accidentally redefine it, things like that. So usually you should be using sort of const and let these days, but there are sort of subtle advantages of the other ones, but that's the main breakdown, I would say. So let's get back to this. We were trying to find the first split in each of these things. So will that replace all them with an empty space? Doesn't look like it. Oh, because that's an actual regex value. So I'm just trying to find a way to find and replace brackets. Brackets on string JavaScript. Here we go. We've already got a nice doggy. Somebody else has already written this exact function, luckily, so we can just make use of that. And we can return. Oh, we don't want to return that, but let's console log this while we're here anyway. String is not defined. I should be using this num variable that we've got. So there we go. Now we've got it without all of our brackets, so it looks a bit easier to find that. Next, I want to split that into an array. So I'm going to use the split function. I'm going to split it on commas. So that should create me a list or an array just of those numbers. So again, let's console log. Actually, let's store that. Nums equal. So here's where we could use const, because we're not going to change those numbers once we found them. I won't be able to do that. Console.log nums. So there we go. There's all our numbers. Now we're just looking for the biggest number. So get biggest number in a list. You'll see I Google everything, because I could write these myself, but normally someone else has already written the obvious stuff. So there we go. We've got math.max. Math.max nums. So we should be looking for 15 here. Oh. I need to use the spread operator so it will get all the different values from there. There's our 15. Then we need the index of that 15. So const max equals math.max nums. And we can log out the index. Oh, it's not called array, it's called num. So that should be the position of our well, it's not in num, it's in nums. -1. Console.log nums. So we should be seeing 0, 1, 2, 3. Weird. Because they're strings instead of numbers, so I need to convert this to a string. I think there's a toString method in JavaScript. Oh no, string. toString? Num toString toString like that. There we go, we've got our 3. Why is that useful? Why do I want that? I want its position in the actual I guess I want its position in the actual number. So I want this 13, 1, 2, sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, looks good. Then I want to split the number. So once new num equals a list, and we're going to have max. Well, for now, let's say max divided by 2, max divided by 2. And let's console.log that new num. New num. So there we've got 7.5 and 7.5, though we know this should be 7 and 8, right? So this is what they meant by the sort of, this is a function called flooring and ceiling. So floor, we take we round it down. Ceiling, we round it up. So there we've got 7, you can see. Math.ceil for ceiling. So there we go. So we've successfully got the split there. Now we just need to put this where that number was. So we need to replace it. So console.log is, again, unique to JavaScript. So in other languages, you might see like system.print.outline, I think is in Java, or just the word print, but this is just JavaScript's equivalent to that. So the console refers to all this stuff out here. Normally you want to log, but there's other things like warning, errors, all sorts of logs you can use. And then whatever string you pass into there will be printed out on this right-hand side. So it can be quite a good way to sort of debug stuff as you're writing it. Right, so I just need to push this into this position now. I guess we've found the split. Get split. Actually, let's just call it split, and let's just do the splitting in here. So now we've got that, we need to do some equivalent. How are we going to do this? I can't just replace the character because the character could be different length, right? It could be like 100, it could be 1. Although we'd never be splitting one less than 2. You just hope that it was never one bigger than that. Console, people would refer to this over here as the console. You can see this word at the top. So it's just sort of an older version of the interfaces we use now that is entirely text-based, where you type your commands in here and you try and navigate through files. So this still exists on most computers. So you can open up your command prompt and see that you also have a console if you're using Windows just by typing cmd. And this is just an alternate way of navigating your computer, running looking for files, writing code. Just now we have nice graphical user interfaces we can use instead. But when you're programming, you're much more likely to have to use that console to install something, to build your project, all sorts of stuff, basically. Right, so let's tidy up a little bit. I'll get rid of some of these console logs. We can leave those. Right, so I need to push this into its position. So I guess I can say like return num split up to the index. Ooh. No, not split, sorry, splice index. If I do this, insert string inside string at index JavaScript. Slice is what I want. So we're returning num slice up to the index, and probably just after the index. Find split. I guess I renamed it. And then I've returned that number, so I want to do console.log of that number. And there you go, you see it's replaced the 15 with our bar, so we just need to replace it with the new number instead. Probably a toString of that new number. 78, not quite right. Maybe we'll benefit from using one of these string templates again here, so we can do square brackets, dollar, new number, close the square brackets, close the string template. There we go, that's looking good. So I guess we could have compared it if I hadn't deleted the line, but now I'm going to bring those lines back anyway. So here we go, we've got that start line, and the end line was just the inserting of a 7, 8 there. So I think now we could successfully split if we needed to. There's still loads to do exploding wise. I'm going to wrap it up here, so if you've got any other questions, feel free to put them in the chat and I'll leave the stream up a little bit longer. Chris, if you want to ask, like, where's, I don't know what your level's at, but where would be a good next best place to continue learning JavaScript if you're interested in JavaScript, I suggest Code Academy. So that's called a string, is it template literals? JavaScript, yeah. So check this out for the $ stuff in the chat now. But yeah, otherwise I'd suggest you check out this site. It's quite a good site to learn stuff. But otherwise, I'll leave it there and I'll see you later. See you next week. Bye-bye.